All right, let's dive into something really cool today. We're looking at a paper from researchers at Google and Princeton that is completely changing how we think about AI solving problems. It's a framework called ReAct, and it's all about teaching an AI to do something we do without even thinking, reason about a problem, and then actually act on that reasoning in the real world. But before we get into the AI, let's talk about you. How do you solve a super simple, everyday problem? Let's say you're cooking, you need the pepper shaker. You don't just, magically have it appear in your hand. There's a little process, a tiny loop that your brain is constantly running. And it goes a little something like this. First, you have a thought. Okay, I need the pepper shaker. Then you perform an action based on that thought. You walk over to the countertop. And finally, you make an observation. You look, and hey, there it is. Think, act, observe. This simple little loop is the secret sauce for how we get anything done. And, it turns out, it's exactly what AI has been missing.
See, before ReAct came along, large language models were kind of stuck. They were generally built in one of two ways, and you can almost think of them as having two different and pretty flawed kinds of minds. So on one hand, you've got what we can call the thinker. This AI is fantastic at reasoning. It can string ideas together, create logical steps, but it's completely trapped inside its own head. It can't actually check anything in the real world. Then on the other side, you've got the doer. This AI is all about action. It can use tools, it can perform tasks, but it has zero ability to reason or plan. And as you can imagine, both of these approaches have a huge, fatal flaw.
Let's start with the thinker. You ask it what other devices can control the same program the Apple remote was originally designed for. It spits out this reasoning that, well, it sounds totally legit, right? But it's completely wrong, because it has no way to check its facts with reality. It just starts making stuff up. This is what researchers call hallucination, and believe me, it is a massive problem.
Okay, now let's look at the doer. In this little simulation, it's trying to find that pepper shaker. It tries to grab one from the sink, and the system reports back, nothing happens. There's no pepper shaker there. Now you or I would immediately go, okay, that didn't work, let's try the cupboard. But the doer, it can't think. So what does it do next? It tries the exact same failed action again. And it would do it again and again. It's just stuck in this dumb loop of failure because it can't reason about why it failed and come up with a new plan. So you've got this AI that thinks but can't act, and another that acts but can't think. The breakthrough of the ReAct framework is just so simple, it's brilliant. What if you just put them together?
ReAct, it literally stands for reason plus act. The whole idea is to teach the AI to weave its thoughts, its reasoning, and its actions together in a constant back and forth. It's not just think, then act. It's a dynamic cycle. Let's actually see what that looks like. Let's go back to that Apple remote question. The ReAct agent starts by generating a thought, just like we would. It's like its own internal monologue, its plan of attack. It says, okay, my first step is to search for Apple remote and figure out what it was made for. And that thought immediately triggers an action. The AI doesn't just guess, it actually does something. It uses a tool, in this case a Wikipedia search, to go out into the real world and get information. And that action gives it an observation. The search result comes back with real solid facts. Now here's the magic. This observation feeds directly back into the AI for its next thought. This grounds its reasoning in reality. It keeps it from hallucinating. It now knows the answer has to do with something called front row, not the iPhone. So, this all sounds like a neat idea, but does it actually work? Oh yeah. The researchers put this thing through its paces, and the results are pretty stunning. It dramatically improves how well the AI can handle complex tasks.
So they tested ReAct in this really complicated text-based game called ALFWorld. The previous best approach only succeeded about 37% of the time. Our doer model, the act-only agent, did a little better at 45%. But ReAct, by combining that thinking and doing, just look at it. It hit an incredible 71% success rate.
To put that in perspective, that is an absolute jump of 34 percentage points over what was considered state-of-the-art. We're not talking about a tiny little improvement here. This is a gigantic leap forward in capability.
But, getting higher scores is great, but this is where ReAct gets really interesting. By forcing the AI to show its work, to show its thinking, it introduces something that's arguably way more important: trustworthiness.
This whole approach just makes the AI's decision-making process transparent. It's no longer a mysterious black box.
And because we can actually see what it's thinking, we can finally do something that was pretty much impossible before.
I mean, think about it. We can actually watch its thought process unfold. We can see when it's using its own internal knowledge versus when it's using facts it just looked up. And maybe, most importantly, we can pinpoint the exact moment its logic goes off the rails. And that means we can diagnose why it failed, and we can even step in to fix it. Here's a perfect example from the paper. The AI is looking for 2 keychains. Now, it's already checked drawer number 4 and found nothing. But then it kind of hallucinates, it gets confused, and it writes down this thought that it can find the second keychain there later. This is a critical mistake that would have made it fail the task.
But because that flawed thought is written down where we can see it, a human operator can spot the mistake. And this is the truly mind-blowing part. The human can intervene.
A person can literally go in and edit the AI's line of thought. They just correct the bad reasoning and give it a little hint. Hey, the second keychain is probably in the dresser. And just like that, the AI accepts the correction, gets back on track, and succeeds. This isn't just supervising an AI, it's like collaborating with its thought process.
And that's really where this leaves us, with this fascinating question. The ReAct framework gives us an AI that can reason, it can act, and crucially, it can be guided and corrected by us. It's not just a tool in a black box anymore. It's starting to look a whole lot more like a partner. And you really have to wonder, what is that partnership going to look like?